Greetings to everyone. I thank for the opportunity given for me as a keynote speaker to deliver a lecture on Industrial Internet of Things IoT, its impact on the design of automation systems. I'm Dr. Santosh Krishna from New Horizon College of Engineering, Bengaluru, Karnataka, India. So today's topic is on Industrial Internet of Things IoT. What is the impact on the design of automation systems? So first, let us start with something called as is it evolution or revolution? It is $1 million question. So from evolution to revolution, what happens? So now we have taken an example of early carriage where the carriage to become a more fancy carriage, still it is a carriage, it is an evolution. When that carriage has become an early automobile in a faster period, we call it as a revolution. Similarly, we can have a second example, a vintage analog phone to fancy digital phone, it is an evolution period, whereas from the digital phone to the smartphone, it is an revolution. So, evolution is a gradual process in which something changes progressively from one stage to another stage, whereas revolution is a total turnaround, sudden, complete, drastic change, fundamentally radical change in something. We call it as revolution. So, the same thing happens in the case of IoT also, evolution to revolution. Evolution refers to gradual changes over a period of time, whereas revolution, sudden change. The Internet of Things IoT was first coined in 1999 but really took a flight around 2008 when there were more connected devices than the people living on the earth. Arguably, this is when the revolution of the IoT started, sudden radical change from 2008. There has been a huge surge in smart connected devices where devices connected devices were more than the humans. Whether this may be a wearable, self-driving cars, sensors, smart homes, or anything Industry 4.0, smart factories is Industry 4.0, which we'll be discussing for next few slides. We are all now using we are in the midst of a smart environment to some extent. So what is the path of Industry 4.0 via IoT? So first that started with Industry 1.0, it's the basic industrial revolution where the introduction of mechanical production equipment was driven by water and steam power. It is really in the 18th century mechanical loop. By the end of the 18th century, this Industry 4.1 was framed. Then in the end of 19th century, Industry 2.0 has come where the mass manufacturing production lines were introduced by electric energy from water stream to now we are to electrical energy. Vintage electrical conveyor belt is an example we have shown there. Then from 2.0 to 3.0, the introduction of electronics. Here where the electronics has come into the picture. 3.0 in the 20th generation, PLCs, SCADA robots in order to automate and production has become here. Now we are in the fourth revolution, that is Industry 4.0, because of the introduction of IoT, Industrial Internet of Things. What we are discussing is basically it is Internet of Things and cyber physical systems driven by AR, augmented reality, and real-time intelligence. So the level of complexity is keep on growing when new technologies come inside. Now when IoT comes into picture, the challenges are also growing on some extent. Now what is IoT? We'll see the introduction about basic IoT, what is Internet of Things is. So I have taken two examples. One is a smart refrigerator, other one is a smart thermostat, where when we have an example like we forgot to buy some milk and some in the midnight when we feel hungry, we have nothing to have at that time. So when a refrigerator can able to remind us to purchase, buy milk and keep it in the fridge, it will be a boon to us, really. Yes. So what are the vegetables is there in the fridge? What is the condition of those vegetables now? We need to purchase some more vegetables which are not there in the refrigerator. For all these things, a refrigerator reminds us, just like mother reminds us son it will be about to us, right? Second one is thermostat. So this thermostat, when we want to adjust a temperature before reaching our home, the air conditioner temperature, that can be done now with the help of this smart thermostat. When we continuously use the temperature at the same time, if it is 11 o'clock in the night, we'll use the certain temperature. If we are fixing with that temperature for some days, with the help of machine learning, data learning, the air conditioner will adjust itself to the particular temperature when the time comes. So these are becoming, machines are becoming smart, and we are becoming smarter to train the machines as well. So what is the IoT? Who is the father of IoT? Kevin Astron is the father of IoT. He believed IoT could turn the world into data that could be used to make macro decisions on resource utilization. So information is a great way to reduce the waste, increase the efficiency, and that's really what the Internet of Things provides. So when we have more data, we are able to do something more. The machines learn from the data what we provide, then it will teach us what to be done, right? That is Internet of Things. For now, we should thank Kevin Eston, who has coined the Internet of Things during his job at MIT to ID Center. Oh, really, definition is still, see, Internet of Things is still growing on, so still definitions are coming up. IoT is usually abbreviated as Internet of Things, can be described as Internet for everything. Everything here means everything is everything. So that to put it simple, IoT is an internet technology that is used for every aspect in this life, especially works that are usually done manually with human labors. So the definition of IoT is, as told, it is evolving as the term is increasingly being used to describe objects that interact and speak. So what is this everything to everything? Anything, any device, anytime, any context, anybody, anyone, any service, any business, any path, anywhere, any place. So anything is connected to any other thing, which means everything is being connected to every other device. It is called as Internet of Things. Machines do communicate with the machines. So, Internet of Things is a scenario in which everything is provided with unique identity and is equipped with ability to automatically transfer the data over a network without any sort of human intervention. Simply put, everything in IP address. We know that IP address is a unique address given to the device, and with that predefined logic, it is able to communicate with themselves. Anything to anything, everything to everything. So this is the Gartner's IoT reference model. There is a Cisco's reference model as well. I have taken only Gartner IoT reference model, where we have totally 5 layers, right from device layer, communication layer, information layer, function layer, and process layer. Device layer is one in which the devices are taken, sensors, because sensors are the one which is forming the base heart of IoT. Sensors gather the data, and that data is being communicated to the communication layer, where the communication layer will have its own protocols called as communication protocols, a network technology, and communication service providers as well. From here, we are giving the data to the information layer, where the information layer will gather all the data and it will segregate the data, whether it is an unstructured data or structured data or metadata, whatever it may be. It is information layer responsibility to segregate it and giving it to the function layer, where the function layer will utilize the machine learning or deep learning algorithms or analytics as being done, so that it will come into the programming stage. Then it can be given an automation stage in the process layer, where certain governance rules standards we should give it. Then it can be applied to the business applications, and the main importance is security. We'll talk about what are the challenges of using the IoT in the coming slides. For now, we can see that in all the layers we have something called as common called as security, which means that security is very important since we are going to make the machines to communicate with the machines directly. So security is very much important when we go into the IoT sector. So how big is the IoT market? IoT market, this is an analysis which is given by Transformer Insights very recently. It has given a prediction from 2019 to 2030 what it will happen. At the end of 2019, there are 7.6 billion active IoT devices according to the new research published by Transformer Insights. This will grow to 24.5 billion, so 24.1 billion in 2030, compound annual growth of 11%. It's very big growth where this 24.1 billion devices will be there, where the economy will grow up to 1.5 trillion in 2030. So the major contributors are China, which is of 26%, North America of 24%, and Europe it is of 23%. So with this, we can able to predict that IoT market is going to be a very big market in the very near future. Now, IoT use cases. Where do we use this IoT? IoT are everywhere now, right from smart wearables, smart homes, smart city, smart agriculture, connected smart cars, smart healthcare, industry automation, and smart energy as well. So wherever we use the word smart, IoT plays a major role there, right from wearables to energy producing. So what is Industrial Internet of Things, IoT? Industrial IoT or Industrial Internet of Things is a vital element of Industry 4.0. The principal driver of this IoT is smart machines. Why? For the two reasons. The first one, smart machines capture and analyze the data in real-time mode which humans cannot. Humans cannot sit continuously and monitor the data continuously, where the machines can able to capture and analyze the data in real time. Second one is that smart machines communicate their findings in a very smarter way, in a simple, fast, enabling faster and more accurate business decisions. So these are the two main key drivers of IoT. The first one is the machine are smart. Machines can capture and analyze the data in real-time mode, which humans will feel difficult. Second one is that smart machines communicate their findings in a manner that is simple, fast, enabling faster and more accurate business decisions are being taken. Next, what are the applications? Where do we have this IoT? IoT is used across a range of industries from manufacturing, logistics, oil and gas, transportation, mining, aviation, energy and more. Its focus is to optimize operations. Very particularly if I say automation of process and maintenance, we can see on the right side, we have given industry 4.0 where right from sensors, monitoring tools, automation, safety, security, quality, industrial applications, network centric, industrial IoT, all these are together, we call it as Industry 4.0. In the long run, it moves to the industry towards a demand service model, increases the customer intimacy, and creates a new revenue systems. For example, this IoT we are having as in a smart city from the smartphone. During the pandemic situation, we came to know that we are alone. We are being alone. We are completely isolated from the city, from the town, from the village, from our own caretakers. We are isolated. In that case, in that time, governments have taken many steps. Many technologies have came in so that today, while we're sitting in a place in different country, I'm talking to you in a real-time mode with the help of technology. Correct. So IoT will play a very major role in the near future when we need to create a smart cities, smart industries, smart environments. This IoT will play a major role where today we are talking about the industrial internet of things. Real world of IoT values. See, we have two conditions. One is for the factory what is needed, for the machines what is needed. For the factory, we need smart operations to be done, system analytics should be proper, production statistics, machine health, optimizations should be done. Whereas in the case of machines, if I say the machine should be smart things, remote access can be should be there, remote management should be there, it should have an IT integrated services and business intelligence as well. So For the factory, for the machines, we need smart operations and smart things. Combined together, we are having smart industry, industry, Internet of Things. What is the critical role of sensors in the IoT? See, before we have coined this term IoT, we are using the term sensor networks, where source and sinks play a major role. Same thing, now sensors are a part of the IoT. IoT is not something which has boomed, just came into existence as all of a sudden. From the sensor network, sensor technology, now it has been evolved into an IoT technology. So, what are the barriers for IoT adoption? Right from societal concerns, is there lack of skilled workforce. So, manpower is very big problem. Though machines can able to do the works, human beings are very much important. Privacy concerns, technology maturity, legacy equipments, uncertain ROI, security concerns, and lack of interoperability are standards. See, that is one which is very big thing, because when we build a machine with some technology here and when we bring it to some other country, if it is not standardized, we cannot use it globally. The ports will be different, the techniques, communication devices will be different. So when all these things are barriers are there, we cannot easily adopt IoT as just like that. So it should have, if in reverse case, if I say technology should be matured, privacy should be more, skilled workforce should be there, and security should be more, and interoperability and standards should get increased. Only in that case, I'll be able to adopt this IoT in a very proper way. What are the challenges with industrial IoT integration? Challenges, we have very good challenges ahead. First one is high investment cost. Second one is secure data storage and management. Third one, connectivity outages. Fourth one, blending legacy and IoT infrastructure. Like when the cost is more, when secure data storage and management is should be there. Connectivity outages, blending legacy and IoT infrastructure. These are the major challenges of integrating this IoT into the industry. So first one is high investment cost. One of the most important is cost. So government should start spending on research on IoT first. So more research should be done, because when we implement this IoT or to IoT or IoMT, medical things or Internet of Things for industry, automation, wherever, we should have be more confident that since research has been done and we have got proper outputs, our failure rates will be less. We'll be able to see what is happening. However, it is very hard for the organizations to justify the cost, because they are not entirely sure what kind of ROI should expect, and they do not have experience in implementing the connected systems. Now, industries are not completely connected with systems. So, according to the Microsoft's 2019 IoT Signals report, 29% of organizations reported that lack of resources one of the top reasons for holding of IoT adoption. So the first one is resources. Investment costs are not there. So government should able to come forward and fund more to produce more resources for investing on industries to become automation, this IoT industries. Second one is very important, secure data storage and management. See, we have IoT devices generate a ton of data. For example, if I fix a small sensor to monitor the temperature of this room, every minute it will generate some data. So we have so much of data. So we need so much of space. Now we don't have space in the air. We are creating space in the cloud completely now, right? So many new technologies such as clouds based technologies should come inside. Okay. Given the level of security that IoT technologies demand, organizations should come up with a plan for streamlining the data, monitoring, management, and storage, allowing for fast response times to incoming threats, and which means that organization must plan for secure short-term storage solutions like edge computing, as well as long-term solutions like for long-term edge storage. So Data storage can be of short term or long term or permanently, but storage and data should be more secured. And connectivity. See, if I'm talking to you in between, if I lose the connection, is of no use, correct? So main key challenge that enterprises need to consider ahead of undergoing the big IoT transformation is that there is need for constant uninterrupted connectivity. The main challenge is, even if you're just talking about uninterrupted internet uptime, achieving 100% availability is almost impossible. So whether this is because of maintenance or something else, or some point or another point, connection may be lost. As such, organizations will need to find some suitable vendor who can provide at least 99% connectivity. With IoT outages, the introduction of several risk factors which will go beyond the imagination. When sensors are being used to detect the hazards such as gas leakages, which is a really threat for human life when we don't do it properly. Connectivity should be there. If suppose a sensor is detecting some gas leakage and when connectivity is lost, the information is not reached to the place where it has to be reached. So what is the use of doing it? What is doing or use of doing the automation then? So connectivity is very important. Proper internet connectivity, uninterrupted connectivity is very important. And next one is legacy IoT infrastructure. Because we are having a complex, we will be building an IoT completely automation infrastructure where there are greater chances that our IT admins and IoT engineers have the visibility, access, and control over every single moving piece in the ecosystem. When the organizations deploy these IoT devices on legacy equipment and various devices are made by different vendors, it is difficult to standardize it. And since it is not standardized, then it is difficult to monitor as well. So, since there is no standard for how to ensure the interoperability or a secure system that includes equipment that was never meant to be smart, that is a fun thing which is again becoming a very big problem to us. Building an environment completely automation, interoperability should be considered very importantly. So we need to build a standard IoT infrastructure. When then we need to, what is the tips for bringing the IoT into your manufacturing business? If you need to bring IoT into your manufacturing business, these are the few points which we need to follow. Organizations should have the following in place to be considered 100% IoT enabled. First one is the machinery which is enabled with sensors and software capable of collecting and organizing data. First one, we should have the machinery which will be able to collect the data from the sensors and able to organize those data in a proper way. Second one, we should have a robust cloud or edge computing systems which can able to store the data or process the data when in real time. So when large number of data is arrived, the cloud should be able to accommodate that. So next one, advanced analytics systems which will allow the teams to attract and analyze data from the connected systems, because devices are getting connected by themselves, the data is being generated and it is stored somewhere, and analytics should be made using some sort of supply chain optimization, asset management, and anything else can be used there. And very importantly, though the last point is that one is not a least point, is very important point, employees with a deep knowledge of how to put insights into action to ensure productivity and uptime. Employees should have a very good knowledge. Though machines do work everything, without humans it is not possible completely. So humans will involve at least to monitor the machines once what it is doing. So in that case, with employees should have a deep knowledge of how to put insights into actions to ensure productivity and uptime. As my concluding remarks, digitalization has been an objective since the earliest days of computers. Now, with sensors and communication, making IoT affordable can be included in every organization's strategy. Industrial IoT is already having a significant effect on most of the industries, and it will increasingly be used as a catalyst for digital transformation as well. So my last remarks is concluding remarks is I would like to tell that though everything will become automation, industrial internet of things are smart homes, smart things, main key players are the human beings. So without that, it is not possible. We are not replacing the humans with machines. We are making the machines to be more active, automation, more automotive, more active, more smart with the knowledge of humans. Humans play a key role in doing all these things. With this, I thank for the opportunity given. I would like to thank the secretary of this international conference for your hospitality. Thank you.